So we have just seen the how to obtain the transfer function. Sorry, how to obtain the state model from the transfer function. So there is a second method for finding the state model from the transfer function. This is especially by using the help of a signal flow graph. First of all, we will draw the signal flow graph of the transfer function. Then after that, by using the signal flow graph, we will find the state model. Okay. So our question is the same. Y of s by u of s, that is the transfer function, is equal to 10 by s cube plus 4s square plus 2s plus 1. Obtain the state model. Okay, so we are asked to find the state model. Now this y of s by u of s, 10 divided by denominator. So we are making some changes in the denominator. S cube is taken outside. So s cube, when s cube goes outside, so we are putting a bracket here. So 1 plus 4 by s plus 2 by s square plus 1 by s cube. Okay, s cube going to multiply. We can see this is s cube plus s cube into 4 by s. So that is 4s square. S cube into 2 by s square, that is 2s, plus s cube into 1 by s cube, that is equal to 1. Okay, so this s cube is taken outside here. So after that, this s cube actually that goes to the numerator. So when it is going to the numerator, it will become 10 by s cube. Okay, so s cube goes to the numerator, that becomes 10 by s cube. So in the denominator, so the remaining part, we are putting it in this way, that's 1 minus, so we are putting the other terms in a bracket. Okay, 1 minus 4 by s, this plus 4 by s will become minus 4 by s, minus 2 by s square, minus 1 by s cube. So if we multiply, this takes this minus inside, this will become plus, plus, plus. Okay, so that is correct. Okay, so 1 minus 4 by s, minus 2 by s square, minus 1 by s cube. So we have modified the given transfer function in this way. Now let us take a review of the signal flow graph. Okay, so how to obtain the signal flow graph? So in the case of signal flow graph, we are using the Mason's gain formula. Okay, so we are using the Mason's gain formula for finding the signal flow graph. Okay, let us use the Mason's gain formula in order to find the signal flow graph. So what is the Mason's gain formula? So transfer function T is equal to summation pk delta k divided by delta. That is the Mason's gain formula. Pk is a forward path gain. So we all know pk is the forward path gain, and delta is equal to what? 1 minus sum of loop gains. So this is the most simple form of the Mason's gain formula. Simply we know that pk is a forward path gain, so numerator containing the forward path gain, and divided by denominator delta is equal to 1 minus sum of loop gains. Okay, sum of loop gains. So we are considering that delta k is equal to 1. Okay, so here we are taking the delta k is equal to 1. And also we have seen the inverse Laplace transform. S times y of s is equal to d by dt of y of t, that is a derivative. Similarly, inverse Laplace transform of y of s by s. So s times y of s, then we are getting the derivative. Then y of s by s, in the case we will be getting the integration. So integral y of t dt. Okay. So if you want to, so y of s by s means we are getting the integration. So that means in the signal flow graph there is a node whose value is s x എന്നുള്ള value ആണ് ഈ നോഡിൻ്റെതെങ്കിൽ. So we will be getting the derivative. So we have to multiply the value by s. So if we are putting the gain as s, then we are thinking that we are getting the derivative. Similarly, there is x dot is a derivative from there. If we want to find x dot in a derivative in x, we have to find the integration. Okay, so we are simply putting a gain as 1 by s. So we are multiplying it with 1 by s in the s domain. Okay, so s domain 1 by s might multiply, that is indicating the integration of the input value. Okay, so x dot, from x dot il ninnum x kittanennundengil we have to multiply it by 1 by s. So 1 by s is indicating the integration. Okay, So ഇത്രയും കാര്യങ്ങൾ മനസ്സിൽ വെച്ചുകൊണ്ട് വേണം നമ്മൾ ഈ സിഗ്നൽ ഫ്ലോ ഗ്രാഫിന്റെ ഫോർമേഷനിലേക്ക് കടക്കാൻ. സോ വാട്ട് നമ്മുടെ മുമ്പിലുള്ള ട്രാൻസ്ഫർ ഫംഗ്ഷൻ എന്നുള്ളത് ഈ ഒരു രീതിയിലാണ്. So from that we are trying to make the signal flow graph. So first of all, let us take the first node as x3 dot. Okay, so from x3 dot we are getting x3. It means we have to find integration. For that we have to multiply by 1 by s. So x3 is nothing but, we have seen the earlier problem, x3 is x2 dot. Okay, so we have to multiply it by 1. So from x2 dot we are going to find x2. So for that we have to integrate it. So we are putting 1 by s. So x2 is nothing but what? x1 dot. So നമ്മുടെ നേരത്തെ പ്രോബ്ലത്തിനകത്ത് നമ്മൾ ഇത് ഡിഫൈൻ ചെയ്തിട്ടുള്ളതാണ്. Okay, so from x1 dot, by using integration we will get x1. So x1 is equal to y എന്ന് നമ്മൾ integrate ചെയ്യും. So x1 is equal to y ആണ് നമ്മൾ ഡിഫൈൻ ചെയ്തിട്ടുള്ളതാണ്. So x1 is equal to y. So this is our forward path. So the numerator ആണ് forward path നെ കാണിക്കുന്നത്. So forward path എന്ന് പറയുമ്പോൾ 10 into 1 by s cube. That means 1 by s into 1 by s into 1 by s. You can see here 1 by s is here into 1 by s into 1 into 1 by s. So as a whole we are getting 1 by s cube. So in the numerator, then the gain what is എന്താണ് കുറവുള്ളത്? 10 ആണ് കുറവുള്ളത്. So we are putting another node here. So this will be our input node, and here we are putting the gain as 10. So now you can see from input to output the total gain is 10 into 1 by s into 1 into 1 by s into 1 into 1 by s. So that is equal to 10 by s cube. Okay, so the numerator is okay. So the numerator is indicating the forward path gain. So here the numerator is constructed, or corresponding to the signal flow graph is obtained. Now let us look at the denominator. So denominator 1 minus, these are the 1 minus the sum of loop gains ആണ്. So 3 loop ആണ് നമ്മൾ കാണാൻ പറ്റുന്നത്. So minus 4 by s into ഒരു loop, minus 4 into 1 by s into ഒരു loop, minus 2 into 1 by s square ന്റെ loop, minus 1 by s cube ന്റെ ഒരു loop. Okay, s square ഇവിടെ s cube ഉണ്ടായിരുന്നു. So s cube ന്റെ ഒരു loop. So minus 4 by s, minus 4 by s and minus 4 into 1 by s. How to obtain that loop? So we are connecting it in this way. So this is 1 by s. Other ഒരു loop ആവുമ്പോൾ minus 4 into 1 by s വരണമെന്നുണ്ടെങ്കിൽ we are putting the gain as minus 4 here. Okay. So അടുത്ത loop എന്നുള്ളത് 2 by s square ആണ്. So 1 by s into 1 by s. So ഈ രണ്ട് 1 by s ചേരുമ്പോൾ 1 by s square ആണ്. അപ്പോൾ അതുകൊണ്ട് so we can put the loop here in this way. So 1 by s into 1 by s 1 by s square ആയി തിരിച്ചു വരുമ്പോഴത്തേക്കിനും the reverse path, return path, we will put the gain as minus 2. So this is minus 2 into 1 by s square. So minus 1 into 1 by s cube, 1 by s into 1 by s into 1 by s, 1 by s cube. So 1 by s cube. You can see from here to here 1 by s cube, 1 by s into 1 into 1 by s into 1 into 1 by s. This is forward path is 1 by s cube. In the reverse return ചെയ്തു വരുമ്പോൾ you can see that this return path will have a gain that is equal to minus 1. So these are the 3 loops here. So this the first loop, so this is the second loop, this is the third loop, and we are putting in the Mason's gain formula, so we will get the exact. So this is the signal flow graph constructed from this transfer function. So ee reethilana transfer function no signal flow graph namukku kittana. Now from this signal flow graph, let us find the expression for x1 dot. x1 dot in the expression number. So x1 dot, so this is x1 dot. x1 dot is a sum of x2 into 1 plus x1 into minus 4. Okay, so x1 dot ഇവിടുന്ന് one part is from here. ഇതിന്റെ രണ്ടിന്റെയും കൂടെ sum ആണ് x1 dot. x2 into 1 plus x1 into minus 4. So minus 4x1 plus x2. So x1 dot is equal to minus 4x1 plus 2. Now let us think about x2 dot. So this is x2 dot. What is x2 dot? x3 into 1 from here, x3 into 1, x2 here, that goes here, x1 into minus 2. So minus 2 times x1 plus x3. Similarly, what is x3 dot? x3 dot. x3 dot is from here, you can see here, minus 1 into x1. Okay, so minus x1 plus 10 times u. So this is 10 times u. So these are the state equations we have obtained. So these are the state equations. So by using these state equations, so signal flow graph il state equation കണ്ടുപിടിച്ചു. ഈ state equations use ചെയ്തുകൊണ്ട് നമുക്ക് state model കണ്ടുപിടിച്ചു. So x1 dot, x2 dot, x3 dot is equal to a into x. So this is a into x. X is x1, x2, x2. So what is a here? So in order to find the first row കണ്ടുപിടിക്കാനായിട്ട് we can use this equation, minus x1. x1 dot is equal to minus 4x1. So minus 4x1, 1x2, 0x3, 0u. Okay. x2 minus 2x1. So this is minus 2, 0x2, 1 into x3. So we will put the x3 1 here. U becomes 0. So x3 dot to minus x1. So this is equal to minus 1. x2, x3 and 0 and 0, 0, 10 times u. So this is 10 times u. So this is the state equation. Now what about the output equation? Output is nothing but here as well, y is equal to x1 എന്നുള്ളതാണ് output equation. So that is becomes the output equation, or the matrix form. Output equation, the matrix form, where y is equal to 1, 0, 0, x1, x2, x3. So y is equal to cx plus d u. U is not here, so in equation u illa. So that is why this part, the second part d, is also becoming 0 here. So y is equal to cx. So this is y is equal to x1 എന്നുള്ള equation എന്നാണ്. From the equation we are obtaining the expression for the output equation. Y is equal to 1, 0, 0, x1, x2 into x1, x2, x3. Okay, so this is the state equation and this is the output equation. This is how we are getting the state model from the transfer function by using the signal flow graph. So signal flow graph കണ്ടുപിടിച്ചതിന് ശേഷം transfer function state model ആയിട്ട് convert ചെയ്യുന്ന method ആണ് ഇത്.